Okay, now here comes the tricky part, which hopefully is not too tricky, but we've got repeating decimals to fractions. Okay, the first thing we need to do is we need to set up a simple equation. We're going to say that number 6 here is 45 hundredths repeating decimal, so that 45 hundredths keeps on repeating. So we're going to say x is equal to 4,500 repeating decimal. And what does that mean? That simply means that it's 0.45, 45, 45, 45, and that just keeps on repeating, going on forever and ever. It's a repeating decimal, it doesn't have an end. Okay, well let's count over. We know that if we wanted to get rid of the repeating part, or at least get past that, we would have to move the decimal point 2 places over. So if we multiply x by 100, that would now be 45 and 45 hundredths, which is repeating, keeps on going on. Okay, now here's the trick. We want to get rid of the repeating part. That's the confusing part. And how do we do that? Well, we've got to take away the repeating part, which is x, or 45 hundredths repeating decimal. So x is equal to 45 hundredths repeating decimal forever, right? So let's subtract that. Look what happens. Okay, I get rid of the repeating part. These are going to cancel each other out. They're going to cancel each other out when I subtract, and I'm just left with 45. I can deal with 45. Okay, and then 100x, and if I take away 1x, what am I left with? I'm left with 99x's. Hey, now I have a one-step equation. Okay, and I want to get x all by itself. I want to figure out what this repeating decimal is as a fraction, and sure enough, okay, if I want to get 99x, how do I undo that? I divide it by 99. Okay, I undo multiplication with division, and what I do to one side of the equation, I must do to the other, and there I have it. X is equal to 45 99ths. And if I want to simplify this, which I do, I see that 45 and 99, I can factor a 9 out of both, and I am left with 5/11ths as my final answer in simplest form. Let's take a look at number 7. Okay, same thing here. It looks a little more scary though. It looks like a tenths, hundreds, thousands. I have 6 10,000ths. 6 10,000ths. So x is equal to 6 10,000ths repeating decimal. That means that's just going to keep on going on, repeating again and again. What's going to repeat? Okay, it's going to be the 0.006, 0006, and that's just going to keep on going. Well, we want to try to get a whole number out of this, or a mixed number, so we're going to have to multiply 6 10,000ths by 10,000. So if I had 10,000x, that would be equal to 6 and 006 10,000ths repeating decimal. Okay, well I want to get rid of the repeating decimal part, which I labeled x, so I subtract 6 10,000ths repeating decimal. Okay, I want to get rid of the repeating decimal, so I subtract it, and I'm also going to have to subtract x from 10,000 x's, and what's that going to leave me with? That's going to leave me with 9,999 x's is equal to, well, the repeating decimal part I got rid of, 6. Okay, and now I just want to find out what x is. I just want to find out what x is, this 6 10,000ths repeating decimal in fraction form. So I've got to get rid of the 9,999 x's. Well, I want to divide that out and just have one x. So I divide this side by 9,999, and I do the same thing that this side over here, 9,999. I'm making an equivalent. And when I'm done factoring out all of these, I'm left with x is equal to 6 9,999 ninths. That's a mouthful. Okay, and sure enough, I can factor a 3 out of both the numerator and denominator, and 3 goes into 6 2 times, and 3 goes into 9,999. Whew! 3,333 times. And that is my ridiculously funky fraction that is equal to the ridiculously funky repeating decimal of 6 and 6 ten-thousandths.